Right now, 15 billion miles from Earth, humanity's most distant messenger is revealing secrets that are, honestly, rewriting our understanding of space. Voyager 1 crossed into interstellar space back in 2012, becoming the first human-made object to leave our solar system's protective bubble. But after a terrifying communication blackout in 2023, the spacecraft came back online with data that absolutely stunned scientists. The space between stars isn't the empty void we imagined. It's actually a dynamic, structured environment filled with cosmic weather, invisible boundaries, and phenomena that challenge everything we thought we knew about our galaxy.
The Silent Crisis.
April 2024 brought relief after months of cosmic terror. Voyager 1 had gone completely silent, transmitting only garbled signals that made no sense to NASA engineers at the Jet Propulsion Laboratory. After 46 years of faithful service, humanity's most distant explorer was dying. The culprit was a corrupted memory chip, likely damaged by a cosmic ray strike. The very phenomenon Voyager was studying had wounded it. Engineers faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away, where radio signals take over 22 hours for a round trip. The rescue operation required rerouting code into backup memory areas, essentially giving CPR to a robot that predated most modern computers. By May 2024, the patient showed signs of life, with all 4 science instruments gradually coming back online. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system.
Magnetic mysteries beyond the edge.
The first shock came from Voyager's magnetometer readings after crossing the heliopause. Scientists expected some differences, but the interstellar magnetic field showed a dramatic misalignment compared to our sun's magnetic influence. This wasn't a gradual transition, it was a sharp boundary suggesting something far more significant than anyone had anticipated. The readings point to Voyager 1 entering a magnetic turbulence zone where galactic magnetic fields twist and reconnect in ways that could, honestly, reshape our understanding of galactic structure. These aren't small ripples in space, they're fundamental forces operating on scales larger than our entire solar system. The magnetic field orientations Voyager measures might even channel cosmic material into denser regions, potentially influencing where new stars form in our region of the galaxy. Each measurement reveals that interstellar space has its own magnetic weather patterns, invisible highways of force that guide particles across vast cosmic distances. The spacecraft continues to detect these magnetic anomalies, proving that the space between stars is far more structured and dynamic than anyone predicted.
The Cosmic Ray Avalanche.
Crossing into interstellar space triggered an immediate and honestly shocking discovery. Voyager's cosmic ray detector recorded a sharp spike in high-energy particles accelerated to nearly light speed by distant supernovae and black holes. The increase wasn't gradual, it was abrupt, like stepping through an invisible barrier. This revelation exposed how effectively our sun's heliosphere shields Earth from the harsh radiation environment of interstellar space. We're living in a cosmic oasis, protected from particle bombardment that would be lethal to unshielded life. But the pattern isn't uniform. Voyager has detected systematic variations, suggesting natural radiation corridors, cosmic highways where particles preferentially flow. These measurements hint at larger galactic structures, possibly ancient scars left by stellar explosions that shaped our neighborhood millions of years ago. The spacecraft may be detecting pressure gradients that map onto invisible architecture spanning light years. Each cosmic ray measurement reveals more about the galactic environment, showing that we're not just measuring local conditions, but glimpsing the aftermath of cataclysmic events that continue to influence our cosmic neighborhood today.
Whispers in the Void.
You know, the silence of space doesn't actually exist. Voyager's plasma wave instrument has completely shattered the old myth of cosmic emptiness by detecting these constant low-frequency oscillations that just permeate interstellar space. And these aren't just random fluctuations, no, they're structured signals, suggesting that the space between stars has its own unique acoustic signature. The instrument has even picked up multiple plasma density spikes, kind of like pressure waves moving through an invisible medium out there. Scientists think these could be shock fronts left behind by ancient supernovae that exploded thousands of years ago, still rippling through the interstellar medium today. So Voyager isn't just drifting through emptiness, it's flying through an invisible fog with its own distinct layers and properties. Some regions are hotter, others are denser, and together they create this complex three-dimensional structure that actually resembles weather patterns a lot more than the uniform void scientists once expected. This cosmic hum, it's really the background activity of our galaxy, a constant whisper from the space between stars. The plasma waves are revealing that interstellar space has its own dynamics, its own currents and temperatures, creating an environment that's far more active than anyone could have imagined.
Interstellar weather patterns.
Voyager 1 has actually passed through at least 2 distinct interstellar cloudlets since crossing the boundary, and this has revealed that the space between stars has structure, kind of like an ocean with currents and eddies. These aren't visible clouds though, they're regions where the plasma, dust, and gas density suddenly changes by factors of 2 or even 3 times. The spacecraft's instruments show evidence of these structured plasma ripples with clear boundaries, almost like atmospheric fronts out in space. NASA scientists now believe our sun is moving through the local interstellar cloud, and Voyager is helping to define its outer edges right now. This cloud exists inside the much larger local bubble, which is this enormous cavity created by ancient supernovae. These density shifts, they actually affect Earth's cosmic ray exposure over millennia. As our solar system drifts through different interstellar environments at 450,000 miles per hour, the radiation environment at Earth subtly changes, and that can potentially affect cloud formation and even mutation rates in living organisms. Voyager is showing us that interstellar space isn't just a straight path, it's really a gauntlet of invisible forces that create this complex, ever-changing cosmic landscape, complete with its own weather systems and boundaries.
Digital resurrection.
So, the 2023 communication crisis nearly ended humanity's only direct window into interstellar space. For months, Voyager 1 was transmitting incomprehensible data, its memory corrupted by cosmic ray bombardment. NASA engineers were suddenly facing one of their greatest challenges: remotely repairing a spacecraft that's actually older than most of their careers, and doing it with technology from the Carter administration no less. The solution took unprecedented ingenuity, rerouting decades-old code into backup memory areas while somehow maintaining all the critical functions across a 15 billion-mile gap. And every command took 22 hours to reach the spacecraft, so real-time troubleshooting was just impossible. The team basically performed remote surgery on a patient they couldn't see or touch. In April 2024, they finally had a breakthrough when basic telemetry resumed, and that was followed by the gradual revival of the scientific instruments. By June 2024, all 4 active science instruments were functioning again. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system's protective bubble. The rescue operation showed that even 1970s technology could be revived through innovative engineering, buying us precious additional years of interstellar data collection.
Mapping the invisible galaxy.
Voyager 1 is creating something, well, truly unprecedented, a navigational chart of interstellar space. With every data packet sent back, scientists are able to construct 3-dimensional models of the Milky Way's magnetic and radiation zones, using Voyager's measurements as crucial anchor points. This, honestly, represents the first real-scale cartography of our stellar neighborhood. It's a bit like having a weather satellite, but for the cosmos. The cosmic ray gradients, particle density readings, and magnetic field orientations are revealing natural shields and danger zones, and these could really determine whether humans can safely venture beyond our solar system. The radiation environment that Voyager measures is far more intense than what astronauts face in Earth orbit, which makes these maps absolutely crucial for any future interstellar missions. Some astrophysicists even believe the structures Voyager is mapping may influence star formation patterns across our galactic region. Quietly, the spacecraft is drawing the first blueprint of the space between stars, creating detailed models that get refined with every new measurement. This mapping project has, well, become the foundation for understanding how to navigate the void between stars, potentially guiding future spacecraft through the safest corridors of interstellar space.
The protected oasis.
Voyager's measurements have revealed a profound truth about Earth's place in the cosmos. Our solar system exists within a protective bubble that shields us from an environment far more hostile than anyone realized. The dramatic increase in cosmic radiation beyond the heliopause demonstrates how effectively the sun's magnetic field deflects dangerous particles that would otherwise bombard our planet. This discovery reframes Earth not just as our home, but as our shelter in a cosmic storm. The interstellar medium contains radiation levels that would pose serious threats to unprotected life, making our heliosphere a crucial barrier against galactic hazards. Voyager's data shows that this protection varies as our solar system moves through different interstellar environments over millions of years. The spacecraft's measurements of density variations and magnetic field changes suggest our cosmic neighborhood is far from uniform. We're traveling through a complex landscape of radiation zones, magnetic boundaries, and plasma clouds that create an ever-changing environment around our solar system. Understanding these variations helps explain long-term climate patterns and cosmic ray exposure cycles that may have influenced life's evolution on Earth.
The eternal journey.
Beyond its scientific mission, Voyager 1 carries humanity's most enduring message to the cosmos. The golden record attached to the spacecraft contains sounds, music, greetings in 55 languages, and 116 images representing Earth's diversity. This time capsule is engineered for extreme longevity, designed to survive over 1 billion years in the harsh environment of space. In approximately 40,000 years, Voyager 1 will make its closest approach to the star Gliese 445, passing within 1.6 light-years of this distant red dwarf. Long after Earth's continents have shifted beyond recognition, long after human civilization has evolved or disappeared, this record will endure. Voyager represents humanity's most lasting trace in the universe, an ambassador that will outlive our species. No other human object will leave the heliosphere for decades, making Voyager literally our longest-lasting monument. The spacecraft transforms from a scientific probe into something more profound, a message frozen in time, carrying the essence of who we were in 1977 across the galaxy for eons to come. This cosmic time capsule gives Voyager significance that transcends its scientific achievements, becoming humanity's first tentative step into eternity.
Redefining reality.
The space beyond our solar system isn't the featureless void astronomers once imagined. Voyager 1 has revealed a dynamic structured environment with weather patterns, magnetic topography, and radiation zones that shape our galaxy's invisible architecture. The transition from our solar bubble to interstellar space isn't clean. It's messy, complex, and honestly pretty fascinating. Magnetic fields don't align as expected, radiation environments change dramatically, and plasma waves suggest constant activity we never knew existed. Voyager's discoveries prove that interstellar space has layers, fronts, and boundaries, creating a textured cosmic landscape far more intricate than anyone predicted. The spacecraft continues operating on borrowed time, with NASA making difficult decisions about which instruments to shut down as power gradually fades. Early 2025 saw the cosmic ray detector powered down to extend the overall mission, but 3 science instruments continue transmitting their faint 23-watt signals across the cosmic void. Each day, Voyager 1 operates as a gift of knowledge from humanity's only direct sampling of the space between stars, rewriting textbooks with every transmission from the interstellar frontier. Voyager 1 reached the other side, and the reality is more extraordinary than fiction. The interstellar medium isn't empty. It's a structured, dynamic environment that challenges our understanding of cosmic architecture. From magnetic mysteries to plasma whispers, from radiation avalanches to cosmic weather patterns, Voyager continues revealing secrets that rewrite astronomy textbooks. This incredible journey proves that sometimes the most profound discoveries come from the simplest act of reaching beyond our boundaries. If you love real space exploration without the hype, smash that like button and subscribe to Stellar Tech for more mind-blowing cosmic discoveries. The universe is far stranger than we thought. For decades, we've looked at the moon as the final milestone of a bygone era, a silent gray world covered in dust and craters. But the age of lunar stagnation is over. China's ambitious space program has sent back not just rocks, but a technological revelation, a discovery that reboots our entire understanding of the moon's potential and sparks a new technological race to our celestial doorstep. This isn't just about exploration, it's about the technology that will define our future off-world. Let's power up and explore the details. Anomalous lunar structures. The modern debate about strange objects on the moon was largely ignited by the declassified data from the 1994 Clementine mission. This was a unique partnership between NASA and the United States Department of Defense, designed to space test advanced sensor and imaging technology by putting it through its paces mapping the moon. While it achieved its technical objectives, the 1.8 million images it returned have been scrutinized for decades, for more than just their scientific value. On the moon's far side, a region permanently shielded from our view, some of these images contain features that appear to challenge natural formation theories. Analysts point to formations with strikingly geometric properties and what seem to be the remnants of large broken-down structures. The most cited example is a feature that has been dubbed the pyramid due to its seemingly flat sides and sharp angular peak. The official scientific explanation is that these are simply visual illusions created by a combination of low sun angles, complex geology, and digital compression artifacts from early imaging technology. However, critics argue that specific sections of these images exhibit unusual blurring, suggesting a deliberate attempt to obscure sensitive data, and that the mission's true purpose was a technological reconnaissance of something unexpected. Ancient astronaut connections. The speculation around lunar anomalies is a key pillar of the ancient astronaut hypothesis, which reframes ancient history as a record of human interaction with advanced extraterrestrial technology. This theory examines old myths and artifacts, searching for descriptions of what might be advanced engineering. A famous, though thoroughly debunked piece of lore, is the alleged secret audio from Apollo 11, where Neil Armstrong supposedly describes seeing alien spacecraft. While untrue, it fuels the narrative. This perspective reinterprets ancient texts, like the Sumerian tablets' description of the Anunnaki gods. When a deity instructs his son to wear an eagle's mask for a lunar journey, theorists don't see mythology, they see a technical manual describing a breathing helmet. This technological reinterpretation is applied to artifacts worldwide, including the Wandjina cave paintings in Australia. The figures depicted with their large dark eyes and halo-like helmets are seen not as spirits but as visitors in advanced environmental suits. The theory asks a compelling question: if an early human saw an astronaut today, would they draw a god or a person in a machine? China's groundbreaking discovery. While theories of ancient tech remain debated, China's space program has delivered undeniable technological triumphs. The Chang'e 5 mission in December 2020 was an engineering marvel of automation and robotics. It executed a precision landing, deployed a sophisticated drilling and scooping mechanism to collect nearly 2 kilograms of lunar material from different depths, and then successfully launched an ascent vehicle from the moon's surface, a feat of remote rocketry. After the precious cargo was returned to Earth, Chinese material scientists made 2 incredible announcements. First, they identified a previously unknown crystal in the samples, naming it Change Site Y. This made China only the 3rd country to discover a new mineral on the moon, showcasing their advanced analytical capabilities. Second, and more importantly, their instruments detected water molecules. This water wasn't in the form of ice but was physically trapped inside microscopic beads of glass that were forged billions of years ago in the intense heat of meteorite impacts. This discovery was a technological game-changer, proving that a vital resource for any off-world operation is far more abundant and accessible than previously thought. Revolutionary implications. The confirmation of widespread water on the moon is, honestly, the single most important technological enabler for humanity's future in space. It makes the engineering principle known as in situ resource utilization, or ISRU, a viable strategy. For decades, the sheer cost of launching every drop of water and ounce of fuel from Earth's deep gravity made the idea of a permanent lunar base, prohibitively expensive. China's discovery changes that financial and logistical calculus entirely. The lunar soil, or regolith, may hold billions of tons of this trapped water. The technology to extract it is actually pretty straightforward. Robotic rovers could be designed to heat the regolith, releasing the water as vapor to be collected. Now this water can sustain life, but its true value is in what it can be converted into. Using electrolysis powered by solar panels, the water molecules can be split into pure hydrogen and oxygen. These are the 2 most potent and efficient components of modern chemical rocket fuel. This technology would allow the moon to become a fully self-sufficient industrial outpost and a refueling depot, radically lowering the cost and increasing the payload capacity for missions to Mars and beyond. The Chang'e program evolution. China's success is honestly a case study in methodical, iterative technological development. Their lunar exploration program was designed as a series of increasingly sophisticated engineering challenges, with each mission serving as a testbed for the next. The program began with the Chang'e 1 and Chang'e 2 orbiters, which were essentially advanced robotic surveyors. creating the high-resolution maps needed for all future surface missions. The next phase was proving their landing technology. Chang'e 3 successfully put a lander and the U-2 rover on the surface in 2013. Having mastered landing, they tackled an even greater challenge with Chang'e 4 in 2019, a landing on the far side of the moon. This required an entirely new piece of infrastructure, a dedicated communications relay satellite positioned in a stable orbit beyond the moon to bounce signals back to Earth. With landing and long-range communication perfected, they moved to the final, most complex phase sample return. The Chang'e 5 mission integrated all of these technologies and added several new ones, including a robotic ascent vehicle and an automated orbital rendezvous system. This deliberate, step-by-step evolution of their tech stack is what has propelled China to the forefront of lunar exploration. Resource revolution on the moon. The Chang'e 5 samples have honestly ignited a technological and economic revolution by confirming the moon's status as a treasure trove of 21st century resources. The new mineral, Change Site Y, is a carrier of an isotope called helium-3. Deposited by solar winds over billions of years, helium-3 is incredibly rare on Earth but abundant on the moon. It is the most sought-after fuel for next-generation nuclear fusion reactors. The technology of helium-3 fusion promises to generate vast amounts of clean, safe energy without the long-term radioactive waste of current fission reactors. The technology to mine and process lunar helium-3 could literally power the Earth for centuries. Furthermore, the lunar regolith is a rich source of rare Earth elements, which are the backbone of our modern high-tech world, used in everything from powerful magnets and electric motors to the electronics in our phones and computers. Developing the advanced robotics and automated mining technologies required to extract these resources on the moon would not only fuel a new space economy, but would also provide a secure and environmentally superior alternative to terrestrial mining operations. Future lunar colonization. With the key technological barriers of water, energy, and materials now seemingly solved, the engineering challenge of building a permanent human base on the moon has come into sharp focus. In March 2021, this moved from concept to formal policy, when China and Russia announced a joint initiative to construct the International Lunar Research Station, or ILRS. This project is a plan for a permanent, expandable, and eventually autonomous human outpost at the lunar South Pole. This site is considered prime real estate because its deep craters, permanently shielded from sunlight, are thought to hold vast reserves of water ice. The ILRS will be a test bed for a new generation of technologies, including closed-loop life support systems, advanced radiation shielding, and construction techniques like 3D printing habitats using native lunar regolith. To power this ambitious undertaking, China has announced plans to develop and deploy a powerful nuclear fission reactor on the moon by 2028, a foundational piece of technology that would provide the consistent energy needed for large-scale industrial operations and colonization efforts. Lunar resources, the new gold rush. The scientific confirmation of the moon's resource wealth has kicked off a high-tech gold rush, creating a global race to develop the technologies for lunar mining and resource extraction. The focal point of this competition is the moon's South Pole, now viewed as the key to a sustainable off-world presence. This technological race, however, is running ahead of international law. The 1967 Outer Space Treaty is the bedrock of space governance and clearly forbids any nation from claiming sovereignty over the moon. But it was written half a century before the technology for lunar mining was considered viable, and so it is dangerously silent on the legality of extracting and owning celestial resources. This legal ambiguity has created a Wild West environment where the First Nations or private companies that successfully demonstrate the technology to mine the moon could establish a powerful precedent, effectively shaping the economic and legal rules for everyone else. This is driving a frantic pace of innovation in robotics, remote sensing, and automated processing, as the finish line isn't just a scientific discovery, but the establishment of a technological foothold. International Space Race. The 21st century space race is defined by competing technological philosophies. The United States is pursuing its return to the moon through NASA's Artemis program, which is structured as a massive public-private partnership. This model outsources the development of critical hardware to innovative commercial companies. For example, NASA has tasked SpaceX with developing its reusable Starship Super Heavy rocket as the primary human landing system, and Blue Origin is building a competing lander. This strategy is designed to accelerate innovation and drive down costs by harnessing the competitive power of the commercial market. This approach is diplomatically extended through the Artemis Accords, an international framework that promotes shared principles for peaceful and transparent space exploration among its many signatory nations. This model of commercially driven, alliance-based development stands in stark contrast to the state-funded, vertically integrated approach of its primary competitors, setting the stage for a fascinating race between two different models of technological progress. Competition between China, US, and other nations. The new lunar race is solidifying into distinct technological blocks. On one side is the US-led Artemis Accords, a large coalition of nations pooling resources and adhering to a common set of operational standards. On the other is the strategic partnership between China and Russia, focused on the development of their joint lunar base, the ILRS, which is building its own coalition of international partners. But this is not merely a two-sided competition. Other nations are rapidly developing their own advanced space technologies and becoming major independent players. In 2023, India's space agency, ISRO, executed a flawless robotic landing with its Chandrayaan-3 mission, becoming the first country in history to successfully touch down near the lunar South Pole. This achievement demonstrated a mastery of advanced autonomous landing systems and put India at the forefront of the search for lunar water. This multipolar landscape, filled with competing government programs and disruptive private companies, is creating an ecosystem of rapid technological advancement. The immense engineering challenges ahead mean that while competition is the current driver, collaboration may be the ultimate key to success. The moon is no longer a distant monument to past glories. It is an active lab, a resource-rich frontier, and the essential technological proving ground for our multiplanetary future. China's discoveries have served as a catalyst, accelerating a new global race to develop the technologies that will allow us to live and work on another world. What piece of technology do you think is most critical for building a lunar base? Let us know your thoughts in the comments. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the stellar tech that is shaping our future. Thanks for watching Stellar Tech. When astronomers discovered Oumuamua in 2017, they thought they'd found a typical interstellar visitor, just a chunk of rock from another star system passing through our cosmic neighborhood. But, 7 years later, the more we learn about interstellar objects, the stranger Oumuamua becomes. The recent discovery of 2 I/Borisov and now 3 I/Atlas has given scientists a baseline for what normal interstellar objects should look like. The problem? Oumuamua doesn't match the pattern at all. Today we're exploring how new interstellar discoveries are making our first cosmic visitor look increasingly alien and mysterious.
The discovery of 3I Atlas.
January 2025 marked a milestone in astronomy, when the Atlas asteroid survey detected what appeared to be a routine asteroid, designated C2023A3. However, months of orbital analysis revealed something extraordinary. This wasn't a solar system object at all, but our third confirmed visitor from interstellar space. Larry Deneau, principal investigator of the Atlas project at the University of Hawaii, initially dismissed the object as typical space debris until precise astrometry revealed its hyperbolic trajectory. Unlike Oumuamua's mysterious behavior, 3I/Atlas behaved exactly as astronomers expected an interstellar comet should. As it approached the sun, the object developed a classic comet tail, began outgassing water vapor and carbon monoxide, and showed predictable brightness variations consistent with a rotating icy nucleus. Robert Warwick, the same astronomer who discovered Oumuamua with the Pan-STARRS telescope, confirmed that 3I/Atlas displayed all the characteristics absent from our first interstellar visitor. The object's composition matched theoretical predictions for comets formed in other star systems, with spectroscopic analysis revealing familiar water ice, carbon dioxide, and rocky material. This normal behavior made Oumuamua's anomalies even more puzzling and significant. The Oumuamua discovery. October 19, 2017, changed our understanding of the cosmos, when Pan-STARRS 1 telescope in Hawaii detected a fast-moving object unlike anything seen before. Robert Warwick was conducting routine asteroid observations when he noticed an object moving too quickly to be bound by the sun's gravity. Initially catalogued as C2017U1, then reclassified as A2017U1 when no comet tail appeared, the object finally received the designation 1I/Oumuamua, the first confirmed interstellar visitor to our solar system. The Hawaiian name means scout or messenger from afar, chosen by the Pan-STARRS team to honor its discovery location. Oumuamua was already leaving the solar system when detected, having made its closest approach to the sun weeks earlier. The object's discovery timeline was incredibly tight. Astronomers had only a few weeks to observe it before it faded beyond detection limits. European Southern Observatory's Very Large Telescope and other major observatories worldwide immediately began tracking campaigns. The International Astronomical Union had to create an entirely new designation system for interstellar objects, with the I prefix distinguishing visitors from other star systems from ordinary asteroids and comets born in our solar system. Oumuamua's strange properties. Oumuamua defied every expectation astronomers had about interstellar objects through its bizarre physical characteristics and behavior. The object measured approximately 400 meters long and only 40 meters wide, creating an unprecedented 10-to-1 aspect ratio that made it the most elongated object ever observed in space. Alan Fitzsimmons from Queen's University Belfast led spectroscopic studies revealing that Oumuamua's surface was dark reddish in color, similar to objects in the outer solar system that have been irradiated by cosmic rays for millions of years. The object rotated every 7.3 hours, creating dramatic brightness variations as different faces reflected varying amounts of sunlight toward Earth. Unlike typical asteroids or comets, Oumuamua showed no signs of outgassing, dust production, or tail formation, despite passing close to the sun, where volatile materials should have vaporized. Marco Michelli from the European Space Agency discovered that the object was gradually accelerating away from the sun, behavior that suggested comet-like outgassing but without any visible evidence of gas or dust emission. Temperature modeling indicated that Oumuamua's surface should have been hot enough to sublimate water ice, yet no outgassing was detected by even the most sensitive instruments available to astronomers worldwide. The acceleration mystery. The most perplexing aspect of Oumuamua emerged when, precise astrometric measurements revealed the object was accelerating away from the sun without any visible mechanism to explain this behavior. Marco Michelli and his team at the European Space Agency used Hubble Space Telescope observations combined with ground-based tracking data to determine that Oumuamua was experiencing a small but measurable non-gravitational acceleration. The acceleration was approximately 100,000th of a meter per second squared, tiny, but significant enough to affect the object's trajectory over time. For typical comets, this type of acceleration results from the rocket effect of outgassing materials as solar heating vaporizes ice and other volatiles from the nucleus. However, Oumuamua showed absolutely no signs of outgassing, dust production, or comet tail formation that would account for the observed acceleration. Davide Farnokia from NASA's Jet Propulsion Laboratory confirmed that the acceleration was real and not an artifact of observational error or gravitational perturbations from known solar system bodies. The mystery deepened when astronomers realized that the acceleration was decreasing as Oumuamua moved farther from the sun, exactly matching the pattern expected from solar-powered outgassing, but without any detectable outgassing occurring. Scientific investigations. NASA's Spitzer Space Telescope conducted crucial observations that, honestly, deepened the Oumuamua mystery rather than solving it. Davide Farnokia led the Spitzer investigation, searching for any infrared signature that might indicate outgassing or thermal emission from the object's surface. The results were shocking. Spitzer detected no thermal emission whatsoever, suggesting Oumuamua's surface was either extremely small or highly reflective. The albedo measurements indicated that Oumuamua reflected approximately 10 times more sunlight than typical asteroids, giving it an unusually bright mirror-like surface. Alan Harris from the German Aerospace Center collaborated on thermal modeling that revealed Oumuamua must be either much smaller than initially estimated or composed of highly reflective material, unlike any known solar system object. The James Webb Space Telescope was unfortunately not yet operational during Oumuamua's passage, but ground-based spectroscopy by teams led by Alan Fitzsimmons revealed a surface composition that appeared similar to organic-rich asteroids from the outer solar system. However, the complete absence of water vapor, carbon monoxide, or dust emission remained unexplained by any conventional model of interstellar object composition and behavior.
The alien hypothesis.
Abraham Loeb, chair of Harvard University's astronomy department, sparked worldwide controversy by proposing that Oumuamua might be an artificial object created by extraterrestrial intelligence. In his analysis published in astrophysical journal Letters with Shmuel Bialy, Loeb suggested that Oumuamua's unusual acceleration could be explained if it were a light sail, an ultra-thin sheet of material propelled by solar radiation pressure. The hypothesis proposed that Oumuamua might be debris from alien technology, possibly a defunct probe or even a deliberately sent investigation device from another civilization. Loeb calculated that a sail-like object only millimeters thick but hundreds of meters wide could experience exactly the type of acceleration observed without requiring outgassing. The artificial origin theory gained traction when Loeb noted that Oumuamua's extreme elongation and high reflectivity were consistent with constructed materials rather than natural rock or ice. NASA's reaction was skeptical but respectful, with Thomas Zurbuchen, former associate administrator for science missions, acknowledging that extraordinary claims required extraordinary evidence but shouldn't be dismissed without investigation. Loeb's hypothesis divided the scientific community, with many astronomers arguing that natural explanations should be exhausted before considering extraterrestrial origins for unusual but not impossible celestial phenomena.
The dark comet theory.
Darrell Seligman from the University of Chicago and Gregory Laughlin from Yale University proposed a natural explanation for Oumuamua's mysterious behavior through their innovative dark comet hypothesis. Their theory suggested that Oumuamua was composed primarily of hydrogen ice, frozen molecular hydrogen that would be invisible to most telescopes and leave no detectable outgassing signature. Hydrogen ice sublimates at extremely low temperatures and produces gas that's nearly impossible to detect with conventional instruments, potentially explaining the acceleration without visible outgassing. The theory required Oumuamua to have formed in an exceptionally cold environment, possibly in the outer regions of another star system where temperatures were low enough for hydrogen to freeze solid. Seligman calculated that objects composed of hydrogen ice could maintain their integrity during interstellar travel, and would begin sublimating as they approached any star, producing the rocket-like acceleration observed. The hydrogen ice hypothesis gained support from theoretical models, showing that such objects could form naturally in protoplanetary disks under specific conditions. However, the theory faced criticism because hydrogen ice has never been observed in space, and would require extraordinary preservation during Oumuamua's millions of years journey through interstellar space before reaching our solar system.
The ongoing debate.
Abraham Loeb remained unconvinced by the dark comet theory, publishing detailed critiques arguing that the hydrogen ice hypothesis created more problems than it solved. In his book Extraterrestrial, the First Sign of Intelligent Life Beyond Earth, Loeb pointed out that hydrogen ice would require formation temperatures of -434 degrees Fahrenheit, colder than most regions of interstellar space. He argued that such an object would likely sublimate completely during its journey to our solar system, making survival impossible over the millions of years required for interstellar travel. Darrell Seligman responded with refined calculations showing that sufficiently large hydrogen ice objects could retain enough material to remain intact, but acknowledged the theory required exceptional formation conditions. The scientific community remained divided, with most astronomers favoring natural explanations, while acknowledging the limitations of current observational data. European Southern Observatory astronomers conducted follow-up studies of other interstellar objects, finding that normal comets like 2I/Borisov behaved exactly as traditional comet models predicted, making Oumuamua's anomalies even more striking. The debate highlighted fundamental gaps in our understanding of interstellar object formation and composition that persist today. Project Lyra mission concept. Andreas Hein from the Initiative for Interstellar Studies and Zach Manchester from Stanford University developed Project Lyra, an ambitious mission concept designed to intercept and study Oumuamua before it disappears forever into interstellar space. The proposed mission would require launching by 2025 to have any chance of reaching the object, using Jupiter and possibly Saturn for gravitational assists to achieve the enormous velocity needed. ESA's Advanced Studies program examined the technical feasibility, concluding that a small CubeSat could theoretically reach Oumuamua by 2054 if launched on a powerful rocket like NASA's SLS or SpaceX's Falcon Heavy. The mission would carry miniaturized instruments including cameras, spectrometers, and possibly a penetrator to sample the object's interior composition. Project Lyra faces enormous technical challenges, including the need for spacecraft to survive decades in space while maintaining operational capability upon arrival. The mission cost estimates range from $500 million to several $billion, making it financially challenging for most space agencies. Despite these obstacles, Project Lyra represents humanity's best chance to definitively determine Oumuamua's true nature and resolve the debate between natural and artificial origins that has captivated both scientists and the public worldwide. The Future Hunt. The Vera C. Rubin Observatory, beginning operations in 2025, promises to revolutionize our ability to detect and study interstellar visitors before they leave the solar system. Mario Jurek from the University of Washington leads the legacy survey of space and time that will discover an estimated 1 interstellar object per year, a dramatic increase from our current rate of discovery. The observatory's wide-field camera and rapid survey capabilities will provide weeks or months of advance warning when interstellar objects approach, allowing detailed study missions to be planned and executed. NASA's Interstellar Probe mission, currently in development, could potentially encounter interstellar objects during its journey beyond the solar system. The comparison between Oumuamua 2I/Borisov and 3I/Atlas has already revealed that our first visitor was genuinely anomalous, rather than representative of typical interstellar objects. As we discover more interstellar visitors, the statistical sample will help determine whether Oumuamua was a rare natural phenomenon or something more extraordinary. The scientific consensus suggests that while artificial origins remain possible, natural explanations involving exotic compositions or formation mechanisms are more likely. However, the mystery of Oumuamua has permanently changed how astronomers approach the study of interstellar objects and the search for potential technosignatures in space. Oumuamua arrived as a mysterious messenger from another star system and left as one of astronomy's greatest unsolved puzzles. The discovery of normal interstellar objects like 2I/Borisov and 3I/Atlas has only made our first visitor appear more anomalous and extraordinary. Whether it was exotic hydrogen ice, alien technology, or something we haven't yet imagined, Oumuamua proved that the universe still holds surprises that challenge our understanding. Subscribe to Stellar Tech for more cosmic mysteries that push the boundaries of science and keep us wondering what else might be traveling between the stars. Voyager 1, a tiny spacecraft the size of a car, is drifting through the unimaginable darkness of space, 14.5 billion miles from Earth. But nearly 50 years later, Voyager is still alive, defying the odds. Recently, this legendary probe has encountered something in the void that has scientists both amazed and deeply concerned. What has there found Voyager? The data streaming back suggests phenomena that challenge everything we thought we knew about interstellar space. Today, we explore Voyager's impossible encounter and what it means for humanity's future among the stars. The birth of a star sailor. The story of Voyager 1 began in the era of Cold War ambition, when NASA sought to expand humanity's horizons beyond Earth orbit. Under the leadership of Dr. Edward Stone, Voyager 1 was designed as a robust spacecraft capable of a grand tour of the outer planets, the first of its kind. Launched on September 5, 1977, from Cape Canaveral, it journeyed towards Jupiter with an array of scientific instruments, including the cosmic ray detector and plasma wave instrument. The spacecraft was engineered to survive decades of space exposure, carrying the hopes of mankind as it ventured boldly where no one had gone before. Dr. Stone's decade-long stewardship ensured the mission's remarkable longevity, setting the stage for an unprecedented exploration of our solar system. Built with 1970s technology that would seem primitive by today's standards, Voyager 1 was nevertheless equipped with instruments sensitive enough to detect the faintest signals from the cosmos. The spacecraft's nuclear power source, designed to last far beyond its primary mission, would prove crucial for its extended journey into the unknown. This remarkable engineering feat would soon carry humanity's message to the stars and beyond. The Grand Tour. Voyager 1's grand tour of the solar system became legendary, lasting over 12 years and bringing humanity close to the gas giants Jupiter, Saturn, Uranus, and Neptune. During flybys, it sent back unparalleled images and life-changing data that redefined our understanding of these colossal planets. Notably, the encounter with Jupiter revealed the planet's turbulent atmosphere and intense magnetic field, reshaping planetary science forever. The spacecraft discovered active volcanoes on Jupiter's moon Io and revealed the complex structure of Saturn's rings in unprecedented detail. Subsequent visits to the outer planets expanded our knowledge of ice giants and their mysterious moon systems. Each planetary encounter used gravitational assist to propel Voyager faster toward the edge of the solar system, a trajectory carefully calculated to maximize scientific return. The spacecraft's cameras captured images that became iconic symbols of human exploration, including the famous pale blue dot photograph of Earth taken from 4 billion miles away. Voyager's trajectory, programmed for a final sprint beyond the solar system, demonstrated NASA's engineering brilliance in interplanetary travel. Today, its legacy continues as it ventures into interstellar space, humanity's first emissary beyond the protective bubble of our sun's influence. The Golden Record. The Golden Record aboard Voyager 1 is a time capsule destined to outlast humanity itself, containing sounds and images representing Earth's diversity. Curated by Dr. Carl Sagan and a committee of scientists and artists, the record includes greetings in 55 languages and music spanning cultures and epochs. Encased in an engraved gold-plated copper disc, it serves as a cosmic message in a bottle, intended for any intelligent life that may encounter it in the distant future. The record also contains scientific information about Earth's location, using pulsar maps devised by Dr. Frank Drake, providing a cosmic roadmap for potential discoverers. Despite its age, the Golden Record remains a testament to human curiosity and hope across the void of space, symbolizing peace and universality. The record includes sounds of Earth, from ocean waves to human heartbeats, from classical music to the laughter of children. It represents humanity at its best, showcasing our diversity while emphasizing our common bonds. Voyager's legacy is as much cultural as scientific, immortalizing humanity beyond our solar system boundaries. This golden message continues its journey through the cosmos, carrying our hopes and dreams to destinations unknown. Years in the void. Years of drifting through the cold void beyond our solar system, Voyager 1 has defied all expectations for spacecraft longevity. Since crossing the heliopause in 2012, it has continuously sent back data about interstellar space despite operating far beyond its design limits. Engineers at NASA Jet Propulsion Laboratory, led by Dr. Suzanne Dodd, have managed to keep the spacecraft operational despite dwindling power supplies and aging components. Voyager's instruments continue to measure the harsh radiation environment far beyond any planet's protective magnetosphere, revealing a cosmos more dangerous and dynamic than anyone imagined. The spacecraft's telemetry reveals vital signs including temperature readings and electrical system status, a testament to the incredible engineering resilience of 1970s technology still performing flawlessly in the most hostile environment known. Each year, Voyager's plutonium power source weakens, forcing mission controllers to make difficult decisions about which instruments to shut down to conserve energy. Yet the spacecraft persists, transmitting scientific data across billions of miles of empty space. Voyager 1's longevity contrasts sharply with initial mission expectations, with scientists noting it has become humanity's longest-lived emissary in the cosmos, far exceeding all predicted operational timelines. Crossing the boundary. Voyager 1's historic crossing of the heliopause marked humanity's first journey into true interstellar space, a milestone that redefined our understanding of the cosmic frontier. The spacecraft's instruments, including sophisticated sensors and detection equipment, began recording phenomena unlike anything seen within our solar system's protective bubble. Lead scientist Dr. George Glockler from the University of Minnesota explains the significance of these observations, revealing magnetic field turbulence and unexpected plasma oscillations that challenge existing models of the interstellar medium. The boundary between solar and galactic space proved far more complex and dynamic than theoretical predictions suggested, showing multiple layers and transitional zones rather than a clean separation. Voyager's data revealed that interstellar space is not the quiet, empty void scientists once imagined, but rather a region filled with electromagnetic activity and cosmic phenomena. The spacecraft detected charged particles moving at incredible velocities, evidence of ancient stellar explosions and cosmic events that occurred millions of years ago. These measurements provided the first direct sampling of materials from beyond our solar system, offering insights into the composition and behavior of the galaxy itself. Voyager's continuing transmission from this unexplored realm offers unprecedented insights into the boundary between solar influence and the vast galactic ocean beyond our protective heliosphere. Signals from nowhere. In late 2023, Voyager 1 went mysteriously silent, sparking fears among mission scientists who had dedicated decades to the project. Analysis revealed a corrupted memory chip, likely damaged by a high-energy cosmic ray that struck the spacecraft with devastating precision. Immediate action by the Jet Propulsion Laboratory team, including Flight Director Dr. Melissa Brown, involved rerouting computer operations to back up memory areas while working across an impossible distance. This delicate software workaround, performed from Earth with signals taking over 22 hours each way, required extraordinary precision and patience from the engineering team. The rescue operation demonstrated incredible human ingenuity, essentially performing remote brain surgery on a patient billions of miles away using technology older than most of the engineers working on it. When Voyager finally responded, it brought relief to scientists worldwide who had feared losing humanity's most distant explorer forever. The incident highlighted both the spacecraft's vulnerability and resilience, showing how a single cosmic particle could threaten decades of scientific discovery. The successful restoration of communication proved that even in the depths of interstellar space, human determination and technical expertise could overcome seemingly impossible odds and continue our journey of cosmic exploration. The temperature mystery. Voyager's instruments have detected bizarre temperature anomalies in the interstellar medium that defy current scientific understanding of cosmic thermodynamics. The spacecraft's sensors recorded unexpected heat signatures and thermal variations that suggest unknown energy sources operating in supposedly empty space. Dr. Reka Winslow from the University of Michigan analyzed data showing these temperature fluctuations correlate with mysterious electromagnetic activity that creates complex thermal gradients across vast distances. These findings indicate dynamic processes previously unknown to science, with energy transfers occurring through mechanisms that current physics cannot fully explain. The spacecraft's thermal sensors detected variations that challenge existing models of interstellar space, revealing an environment far more active and energetically complex than anticipated. These thermal anomalies persist across the spacecraft's trajectory, creating a puzzle that has scientists scrambling to develop new theories about energy distribution in interstellar space. The temperature readings suggest that the void between stars may harbor energy sources or phenomena that could revolutionize our understanding of cosmic physics. Some researchers speculate these thermal signatures could indicate the presence of dark matter interactions or unknown electromagnetic processes that operate on galactic scales, opening entirely new avenues for astrophysical research and discovery. Changing course. Maintaining control over a spacecraft traveling through the depths of interstellar space requires unprecedented precision in navigation techniques and trajectory management. Dr. Carlos Hernandez from NASA Goddard Space Flight Center leads efforts to execute delicate course corrections on Voyager 1, despite the enormous challenges posed by distance and communication delays. These trajectory adjustments must account for the spacecraft's changing orientation, limited fuel reserves, and the gradual degradation of its attitude control systems after decades of operation. The complex calculations required for each maneuver consider gravitational influences from distant stars, the pressure of interstellar particles, and the spacecraft's slowly declining power output. These adjustments demonstrate unparalleled precision in space navigation, requiring engineers to predict and compensate for factors that won't be observable for hours due to signal travel time. Each course correction represents a carefully calculated gamble, as there are no second chances when working with such precious and irreplaceable scientific assets. The navigation team must balance scientific objectives with spacecraft preservation, making difficult decisions about energy expenditure and pointing accuracy. Despite these challenges, Voyager continues to maintain its scientific mission while heading toward an eventual encounter with the star AC plus 79 3888 in approximately 40,000 years. Ghost in the Machine. Recent months have seen Voyager 1's onboard computer systems exhibit mysterious glitches that have puzzled mission engineers and raised concerns about artificial intelligence anomalies. Led by Dr. Ananya Singh at NASA's Jet Propulsion Laboratory, the team closely monitors these strange behaviors manifesting as unexplained error codes and signal irregularities that don't match any known failure modes. The anomalies appear almost intelligent in nature, as if something within the spacecraft's systems is learning and adapting to its environment in ways the original programmers never intended. Some engineers speculate these phenomena arise from cosmic radiation effects interacting with the spacecraft's aging electronics in unexpected ways, while others wonder if decades of exposure to interstellar conditions have somehow altered the computer's fundamental operations. The spacecraft occasionally transmits data patterns that seem to contain information beyond its programmed capabilities, leading to speculation about whether the harsh environment of space might be inducing evolutionary changes in electronic systems. Diligent troubleshooting and software updates aim to preserve communication integrity, but the mysterious behaviors continue to manifest despite all efforts to understand or control them. These electronic anomalies represent one of the most puzzling aspects of Voyager's extended mission. Patterns within patterns. Recent analysis of Voyager's long-term data has revealed subtle but persistent patterns in cosmic ray measurements and magnetic field variations that suggest influences from unknown astrophysical sources. Dr. Amelia Garza, a heliophysics expert from the University of Texas, notes the discovery of quasi-periodic oscillations that appear to originate from deep space phenomena beyond our current understanding. These patterns within patterns challenge assumptions about the uniformity of interstellar space, instead revealing a complex structure operating on multiple scales and timescales that scientists are only beginning to comprehend. The oscillations show characteristics that don't match any known natural phenomena, leading some researchers to speculate about possible artificial origins or previously unknown physical processes occurring in the galactic environment. Voyager's instruments detect synchronizations and correlations in the data that seem too organized to be purely random, suggesting underlying mechanisms that organize matter and energy across vast cosmic distances. These discoveries have profound implications for our understanding of how the galaxy operates, potentially revealing hidden structures or forces that influence the behavior of matter and energy throughout interstellar space. The patterns continue to evolve as Voyager travels deeper into unexplored regions, providing humanity with its first glimpse into the true architecture of our galactic neighborhood and the mysterious forces that shape it. Voyager 1 continues its impossible journey into the cosmic unknown, revealing mysteries that challenge our understanding of the universe itself. From strange temperature anomalies to unexplained computer behaviors, this tiny spacecraft has encountered phenomena that suggest the cosmos holds secrets far beyond our current knowledge. As it drifts ever deeper into interstellar space, Voyager carries not just our scientific instruments, but our hopes and fears about what lies beyond our protective solar bubble. Subscribe to Stellar Tech for more revelations about humanity's greatest adventure and the discoveries that await us in the darkness between the stars.